Hello students, good morning to all of you. Students, in 12th class physics, our today's topic is wave optics, which is the second part of unit 6 optics. In the previous lectures, you will learn about the ray optics, in which we discussed some phenomena like reflection and reflection through prism and some optical instrument on the basis of the some principle like law of reflections and Snell's law. Okay, now some characteristic which cannot be defined on the basis of the ray optics of the light or optics, like Compton effect, photoelectric effect, and yes, okay. So to define the principles which are not defined, categorized or explained on the basis of the ray optics, the second concept occurs in our mind, or in the 400 years ago. Firstly, Newton do some work, or he assumed the light coming from the sun in the form of particles. Those particles are called as corpuscles, or on the basis of these particle corpuscles, Newton gives the theory of corpuscular theory of the propagation of light from from sun to earth. Okay, on the basis of this theory, he assumed that when the ray is traveling from vacuum to or enter in the earth atmosphere, it is traveling in the form of small particles. Those particles massless, and they are able to move with a very fast speed, okay, which is equal to 3 into 10 to the power 8 meter per second. Okay, now because those particles massless, so there is no effect of gravity on those corpuscles or small particles assumed by the Newton. According to him, they have only energy, and at where they hit the surface, the total energy transmit to that particular point at where the surface they hit or fall on the surface. But there is some problem that when the small particle is traveling, so it only gives the energy to that particular place at where it fall on the surface. So the question is arise that when the light travel, then it spread the light energy all around. Okay, which means it brighten the area from where it passes. Okay, so this theory has some limitation, so it cannot be explain the phenomena like interference, diffraction, and the polarization of light. But on the basis of this corpuscular theory, Newton explained the reflection and refraction phenomena of light. So after that in 1678, after the work done by the Newton on the optics, Huygens from Dutch physicist, Christian Huygens, he do some work on the same thing, and he assumed that these small particles are the light particles, and they have some energy, and when they are moving, then each particle behave like a wave. Okay, according to him, suppose we have a point source. Okay, suppose we have a point source of light, then according to him it will illuminate the light energy in all the directions like this. And when we join all these points or point sources, then we get a sphere. And according to his theory, all consecutive points which are used to form this sphere is behave like a wavelet, which means every point is able to regenerate the wave in the same direction as it is traveling earlier. So these are moving like this. And when we join this, so we get a parallel equidistant new sphere, and according to him, every sphere is behave like a wavefront, or every point of this sphere is behave like a wavefront, and this second point is called wavelets, or each wavelet can able to produce the wavefront in the forward direction as the first wavefront is able to. Okay, now some more theories occur in the explanation of this, and it is observed that on the basis of the wave theory we can only explain the phenomena which are based on the simple nature like reflection, refraction, interference of light, deflection of light, and the polarization of light, but it cannot explain the phenomena like photoelectric effect, Compton effect, etc. So this theory is limited to explain the optical phenomena, which means the phenomena related to the ray optics. So after that, electromagnetic theory occurred. On the basis of this electromagnetic theory, James Clerk Maxwell explained the photoelectric effect and Compton effect, but on the basis of it, he cannot explain the theories related to the ray optics. Okay, which means on the basis of the electromagnetic theory of the light waves, reflection and interference, reflection and polarization cannot explain on the basis of the electromagnetic theory. Then after we have the next theory about the wave optics, which is a quantum theory. This theory given by Einstein in 1905, and he used, there is a postulate or hypothesis which is given by the Planck. Okay, on the basis of the Planck theory, according to the Planck theory, the rays coming from the source of sun in the form of a particle, and every particle is known as the photon or phonon. Every photon is behave like an energy particle, and they have energy equal to E equal to h, where h is Planck constant, and nu is frequency of wave. Okay, the value of Planck constant is 6.63 into 10 to the power minus 34 joule second. This is the value of Planck constant, and he also observed that every different color of light have the different value of frequency, so they have a different energy. Okay, now these are the basis of the wave theory. Now we continue with the wavefront and early. right? Wavefronts. Wavefront. What is a wavefront? Okay, so write it. A wavefront is defined as the surface or locus of all points, surface or locus of all points of medium vibrating in the same phase, vibrating in the same phase, which means, let's see here, as you will learn in your previous class, when the sound energy or the wave produced in the pond or a lake, when a small stone is thrown in the lake, okay, like suppose there is a river or a pond, when a pebble is dropped in the pond, okay, then we observe that this is the source of wave origin, okay. So we observe that the wave are originating in such a way that every second wave or every second crash, if it is these all three indicates here crash, and these are indicates here trough. Okay. Therefore, we observe that the every crash is equidistant from the another. Okay. So this is how the wave in the water can produce after dropping a pebble. Okay. If according to the wave theory, suppose a particle of energy, that stone, is traveling in forward direction like this in the form of the transverse wave. So these points are behaved like the crest and the light is traveling in a straight. Okay. So according to him, the light is traveling in the straight line and the point which is pressing the surface is known as wave. Okay. And similarly, when the sound waves are traveling in the medium like air or any other mediums, then their compression and rarefaction is similar to the crest and trough, which gives the direction of motion or direction of propagation of the wave or these waves. Okay, now we can define about ray. That ray is defined as the imaginary line along which the wave travels from one place to the another place. Okay, so what is a ray? So a ray is defined as the imaginary line along which the wave travels from one place to the another place. Okay, now types of wavefront. Next we have type of wavefront. Okay, we have on the basis of the surfaces, we have three types of wavefront. One is if we have a point object which illuminates the light, point object, and when the light is traveling from the point object, okay, then we observe that the light is traveling in the concentric spheres, and each sphere is behave like wavefront. Okay, so this we have the first kind of wavefront, and it is called spherical wavefront. Spherical wavefront. Okay, these are produced from the point source, and as the light is traveling in the forward direction, we observe a large sphere with the same center. So these kind of sphere is behave like a spherical wavefront. So if the source is very far away from us, okay, like this is traveling like this, and the radius of the sphere is increased, okay, then we observe that there is a time for which, if we take the 2 points, it is parallel to each other or in a single line. So if the point source is very far away from the point of observation, then the source is behave like a plane surface. Okay, this is the first condition. Second, cylindrical wavefront. Cylindrical wavefronts. Okay, now what are these? If the source of light is linear, okay, if the source of light is linear, then initially the light is illuminated by the source is like this. Okay, when we join these over lights, then we get it is like a sphere, and this one is again illuminate the light, and we see the point on the forward surface is behave like a secondary wavelet, and they able to produce the wavefront forward in such a way. When the linear source is very far, then the light traveling through it is also behave like a plane surface or plane wavefront. Okay, plane wavefront. Next is plane wavefront. Plane wavefronts. Okay, now what are these plane wavefronts? Okay, so as we discussed in the above 2 cases, point object or spherical wavefront and cylindrical or linear object or cylindrical wavefront. When these sources are very far from the point of observation, then the rays coming from them or wave coming from them light as a plane wavefront. Okay, so these are the types of the wavefront. Clear? Next we have very important part of this chapter, that Huygens, right? According to Huygens principle, there are 2 postulates taken by the Huygens, in which first one is each point on a given wavefront, each point on a given wavefront acts as a source of a new disturbance called the secondary wavelet, which also travel out in all directions with the same velocity as that of the original wave had. Okay, and second postulate is the shape of the position of the wavefront at any later instant is given by the forward envelopes of the secondary wavelets, that is, the surface tangentially to all the secondary wavelets at that instant. Okay, like if we have a cylindrical wavefront and we are taking these 3 points, then these 3 points are traveling in the forward direction, and when we join these with a tangent line, then these points behave like a secondary wavelet, and each secondary wavelet is behave like a wavefront, and they produce the light in forward direction. Okay. Then when we join these all with the help of tangential line, then we get the wavefront like this. Okay. These are the wavefronts, and every secondary wavelet behave like a wavelet. Okay. Next, law of reflection and reflection. This is important part. Verification of law of reflection and refraction on the basis of Huygens theory. Huygens theory. Any one of these is appeared in your exam, either law of reflection or verification of law of reflection on the basis of this theory. Okay, now first we have law of reflection. Law of reflection. Okay, now suppose we have a plane mirror and okay, and wavefront AB incident on the plane mirror at point A. B. This is the primary wavefront whose all the rays are like, okay, they are at 90 at the initial point. Okay, now the wavelet from, or we see a ray of light is traveling from B to the same medium, and incident at point C. Okay, after incident here, it will reflect it from the mirror and traveling in the direction of D. Okay, now if the speed of light in the medium is c and the time taken from the ray by the ray from traveling from B to C is t. Okay, therefore BC equal to C into P. Okay, now as center A and BC as radius, we draw an arc from point A and we observe that that arc is reached here, and then this is joined from C. Okay, therefore this point of touching the arc by joining this is, we say, B dash. Okay, now when we join A to B dash, A to B dash, so we observe that it is equal to BC as per construction. Okay, which is equal to A B dash. It is clear? Because A B dash is the arc taken BC as radius. Okay, now we have two triangles in which this is 90 because this is 90 and this is also 90 because this is the arc, and if this is a circle, so you know the line traveling from center of the circle to the periphery or to the surface is 90. Okay, now in triangle ABC and triangle ABC we observe here angle B equal to angle B dash equal to 9. Okay, second BC equal to AB dash. Okay, by construction. And next AC is formed. Okay, therefore triangle ABC is congruent triangle of AB dash C. Okay, now if this is normal and this is angle of incidence of the primary wavefront, and this angle is equal to angle ABC by construction. Therefore, this is angle of refraction R, and this angle is equal to this. Therefore, angle BAC equal to angle B dash CA, which is angle I equal to angle R. This is by simplicity congruent part of congruent triangles are equal, and this is the first law of reflection, that the angle of incidence is equal to the angle of reflection. Next, all the rays, primary wavefront normal to the surface, and refracted ray is normal to the plane of surface. Therefore, second law is also verified here. Primary wavefront and secondary wavefront and normal and all lies normal to plane. Therefore, second law also verified. Second law also verified. Okay, this is the verification of law of refraction on the basis of the wave theory. Okay, completed. There is some you have to do some writer, like the primary wavefront falls on a plane of meter. Okay, and let the ray traveling from B to C travel a distance C into T, and then after falling at C it reflects in the direction of D, and in the same time the ray reflected from A reach to B dash, okay, in the same medium. Therefore, by taking A as radius and A as center and radius equal to BC, okay, draw an arc which intersect by ray produced from C to the arc touches at B dash. Okay, now from figure in triangle these two we can solve this figure. Okay, next we have verification of law of refraction. Law of refraction. Okay. Okay. Now, for verify law of refraction on the basis of wave theory, like we have a transparent surface and okay, and a primary wave or wavefront falls on it at point A, and the wavelength is AB. Okay. Let the 3 points on the wavefront are A1, A2, A3. Okay, now the ray traveling from B in medium first is falls on the reflecting surface at point C. Okay. Suppose this is first medium of refracting index 1 called air, and this is second medium of refracting index 2 is medium, any medium. Okay, now if the speed of light in first medium is v1 and speed of light in second medium is v2. Okay, therefore the ray travels a distance bc which is equal to v1 into time taken to move from B to C is this. Therefore BC is equal to v1 into t. Clear? Now in the same time t, this is angle of incidence I, and the wave usually travels in this direction, but due to refraction it just bend towards normal and travel to point P. Clear? Now, as A as radius and AB as radius, draw an arc at point P and then this point is joined to C. Clear? So, this is angle R, this is also equal to angle R because this is the another refracted ray, and if this angle is I, therefore we have the two, and here AE is the distance travelled by the ray in the second medium, which is V2, and in the same time T, that is AE equal to V2 into T. It is clear? Now, done? Now, from figure in triangle ABC, in triangle ABC and AEC, we have sine of angle I is equal to perpendicular is BC and hypotenuse BC upon AC, and in this triangle angle of sine R is equal to AE upon hypotenuse AC. Okay, let's say this is first equation and this is second. By dividing equation first and second, equation first divided by second, we get sine I upon sine R is equal to, yes, where AE, this one, no, this is angle of refraction and opposite to the angle is perpendicular. So AE and this is hypotenuse. EC we are taking only when we are calculating value of cos. Okay, so this is BC upon AC and value of R is AE upon AC. Now this is cancelled and we have BC. BC is equal to V1 upon T and V2 upon T. This T cancel and we get sine I upon sine R is equal to V1 upon V2, which is speed of light in first medium to speed of light in second medium, and this ratio is equal to refractive index of second medium with respect to first medium. This is our constant. Okay, this is a constant. And this is also known as Snell's law, and this is verification of Snell's law. Okay, this is this law. Snell's law is verified. Okay, got it? And both the verification on the basis of the wave theory is important. One of them is appeared in your exams. Okay. Thank you.